Tech laboratory tutorial. Today we'll be looking at colligative properties. Colligative properties are properties that shows the number of or amount of solute present in a solution. These colligative properties do not depend on the nature of the solvent. It only depends on the amount measured in moles of the solvent in a solution. And there are factors that affect this colligative property. Number one factor is lowering of the vapor pressure. Lowering of vapor pressure. And number two is elevation of boiling points. Elevation of boiling points. Number three is depression of freezing points. Depression of freezing points. And lastly is the osmotic pressure. And all of these factors have their various calculations because we need to calculate how the vapor pressure of a pure solution is being lowered, or how a vapor pressure of a solvent is lowered. Same with the boiling point. The boiling point also tells us what is the changes if an ideal solution is formed or is a non-ideal solution that is formed. Same with depression of freezing point. So we are going to take them one after the other. Like we earlier said, that an ideal solution follows Ra's law. And this Ra's law says that the partial pressure is equal to the mole fraction times the vapor pressure of a solution. So when lowering vapor pressure, we simply put Pi is equal to mole fraction of 1 times the solution of the pure solvent. So when we want to now calculate the lowering, it means we will say delta P, which is change in the vapor pressure, is equal to P1 minus P solution. What is P? P is the vapor pressure of the solvent, and P degree becomes the vapor pressure of the pure solution. So this is what we need in calculating lowering of vapor pressure. Now we will take examples of how to calculate this lowering of vapor pressure. Okay, so we are taking an example of how do we lower vapor pressure. Glycerin is a non-volatile, non-electrolyte with a density of 1.2 gram per ml at 25 degrees Celsius. The question is, calculate the vapor pressure of the solution made by adding 50 ml of glycerin to 500 ml of water. The vapor pressure of the pure water at 25 degrees Celsius is 23.8 torr, and its density is 1.0 gram per ml. So what comes to your mind is we have to calculate the vapor pressure of the solution. And like I said the vapor pressure of the solution is equal to mole fraction times the vapor pressure of the pure solution. So how do we calculate vapor pressure of solution if we only have the vapor pressure of pure solution? It means we have to calculate the mole fraction. And in calculating the mole fraction, glycerin becomes the solute because glycerin is the one being added to water. So because glycerin is added to water, glycerin becomes solute and water becomes solvent. Therefore, we simply say that P1 will be equal to X times P degree. So X, which is mole fraction, becomes the number of moles of glycerin all over the number of moles of glycerin plus number of moles of water. And how do you know number of moles? We calculate number of moles from mass in gram over the molar mass. Therefore, we need to calculate the molar mass of glycerin. Glycerin molar mass has C3H8O3. So therefore is that carbon is 12, so we say 12 times 3 plus 8 times 1, because the molar mass of hydrogen is 1 and we have 8 molecules of hydrogen, plus we have 3 molecules of oxygen, and we know that the molar mass of oxygen is 16, so it becomes 3 times 16. So when we add this together, we will have 3 times 12 is equals to 36 plus 8 plus 3 times 3, 12 times 3 is equals to 36, 8 times 1 equals to 8, and 3 times 16 will give us 48. When you add up all these together, you will get the molar mass of glycerin. Let's add it together. We have 36 plus 8 plus 48 is equals to 92. So it becomes 92 gram per mole. So we know the formula for density to be mass all over volume. And since density was given to us, our density is 1.26 equals to mass all over. The volume given to us was 50. So it means we multiply 50 to density to get mass of glycerin to be 50 times 1.26, 63 gram of glycerin. So since we know the mass of glycerin and we also know the molar mass of glycerin, it means we can get the number of moles of glycerin. Therefore, the number of moles of glycerin will be equals to 63 all over the molar mass, which is 92. And that gives us 63 divided by 92 will be equals to 0.685 moles. 0.685 moles of glycerin is present. Now that you have done that of glycerin, the next thing is to calculate the number of moles of water, which is the solvent. So just the way we calculated for glycerin, we apply the same thing to water by first looking for the molar mass of water, and we know the molar mass of water is hydrogen is 2, so 2 times 1, oxygen is 16 and is 1 atom, so it's 16 times 1, so together it is 18 gram per mole. Now from the question again, the density of water was given to us as 1 gram per mil. So to calculate for the mass, we simply use mass over volume. That means density times volume is equals to what? Mass. Therefore, density is 1, volume is 500 mil. So when you multiply them, you have 500 gram of water. Now that you have gotten the gram of water, now calculate the number of moles. Number of moles of water is equals to 500 gram all over the molar mass of water, which will give us, just simply press your calculator and you have 500 divided by 18. That will give us 27.78 moles of water. So we've gotten that of glycerin and now we have gotten that of water. So thereafter, it means that we can now calculate for our mole fraction of glycerin. The mole fraction of glycerin will be given to us as what? 0.685 all over 0.685 plus 27 0.78, and therefore it will give us 0.024. Now that we have gotten the mole fraction of glycerin, don't forget we are talking about water. It means we have to get the mole fraction of water. So either you repeat it in the same way, or you simply say 1 minus mole fraction of glycerin is equals to mole fraction of water. So that means mole fraction of water is equals to 1 minus 0.024, and that will give us what? 0.978 moles of water. Then from there we will now calculate for the vapor pressure of water. So the vapor pressure of water is equals to mole fraction of water times pure water, pure solution of water, and that will be PW equals to 0.978 times 23.8. So when we do that, PW becomes 0.978 times 23.8, and that will give us 23.23 torr. So that is the vapor pressure of water that the question asks us to calculate. Then if they now tell you calculate the lowering of the vapor pressure, it means you will not simply say your change in vapor pressure will be equals to vapor pressure of pure minus vapor pressure of the water solution, and thereafter it will be delta P equal to 23.8 minus 23.23, and that will give us what? Vapor pressure lowering to be equal to what? 0.56 torr. Thank you and keep watching. Don't forget to like, share and subscribe.